So today we're on the Henkel booth here at Apex, and I'm joined by Doug Dixon, who's a very well-known face in this industry, Global Marketing Director for Henkel. Welcome, Doug.
Thank you.
Of course, Henkel's just come off the back of a series of very large acquisitions over the last couple of years, and with that it's bringing you countless new technologies and materials, some of which we're going to talk about here today. I think the first one we want to talk about is a reworkable underfill. The UF 3810.
Yeah.
Okay, so it's got a high glass transition temperature, so can you tell me some of the benefits that brings?
Yeah, it's actually the Loctite UF 3810 is a reworkable underfill, which it carries on the next generation of the 3808 material, which was a non-reworkable with some of the similar properties that we had for a 3810,
right.
Which one of the key properties is the reworkability of this material versus the 3808, which is non-reworkable. But what comes out of that is that we actually have a high TG material for a reworkable underfill, which is not the norm.
Normally the low TG.
Right. So one of the other key benefits, of course, for the 3810 is the ability to actually dispense and do the underfill process without heat. So it's a room temperature dispensing application.
Okay, that's a great bonus, isn't it?
Yeah.
So people, obviously some people don't want it reworkable for IP issues, but then others want it reworkable for obvious reasons.
Absolutely.
Okay, good. So the next one we're going to talk about is a chip bonder material, which is non-contact dispensing, or dispensed through a non-contact system. Can you tell us a bit about this?
Yeah, we're talking about the chip bonder, which is 3610, done by Loctite. Henkel's been into actually was the inventor of this technology, so it's been around for a long time, over 20 years.
Right.
So innovators in the industry for material. We'll talk today about the 3621, which is really a chip bonder capable of doing traditional and non-traditional type dispensing, the non-traditional being non-contact or sometimes called jetting.
Right.
So what we find is with our material that you can actually dispense it about 4 times faster than a traditional method with a non-contact. So.
Right.
10,000 versus 40,000 with the non-contact, and we find that the material tested in multiple situations and vendors were able to do very good high quality dots, no telling, no splattering, and the 3621 capable of high lead or lead type wave solder type process.
Right, yeah. And certainly you get a much neater dispensing method using the non-contact and the needles, which can drip and make all sorts of
yeah,
mess.
so it offers a lot of interesting characteristics,
right.
and we're kind of the father of the industry on this technology.
Okay, good. Now, the Macromelt, which has been around for 4 years now.
Yes.
One of your favorite products, I know. I can tell by the look in your face.
I light up every time you say the word.
Yeah. Okay, Macromelt. We've had a couple of interesting improvements here, or not actually improvements, but qualifications, because it's now got a much higher rating from UL, an RTI rating of 95 degrees. So can you tell us something?
Yeah, I mean, Macromelt's been around for us a long time. It's actually an alternative. It's a low pressure mold compound. It's an alternative for conformal coating and potting. So it's a thermoplastic type material. But in this particular material, it's the first time we've actually gone through a UL test at 95C rating on your RTI. So able with a UL qualification, that's pretty good temperatures for a Macromelt thermoset type material.
Very high, yeah. And the other good thing about Macromelt is it's a one-part material as opposed to...
there's no cleaning, no mist, no mix, it's not a 2-part system, no waste, no VOC, so it's a great material.
Okay, and the final piece of news we've got this week is, of course, an interesting little story from a case study, if you like, with one of your customers called Lens Victor, who make innovative camera products, and to help them with this, they're using conductive adhesives. Can you tell us about the conductive adhesive that you've introduced for this application?
Yeah, in this release, we're really talking about LensVector actually using a material of electrically conductive adhesive, an ECA, for a process for mounting the camera in cell phones or other handheld type devices. And the reason they chose it is they needed a material that was capable of handling high humidity type environments, as well as the material was originally designed for non-noble metals. So it actually adheres quite well to things beyond the gold and the silver type finishes. It goes with cheaper finishes that you can use without corrosion, which has typically been one of the major drawbacks of any type of ECI or ECA, is actually inhibits that corrosion and gives you a good process. So we originally designed this material for solar type applications, and now we're seeing it move, this exact same product move into more of a handheld consumer type applications. It's just a great reliable product, and LensVector chose it, and they talk about why they chose it. It's just the ease of use and the reliability that they get out of it.
Right. I mean, traditionally though, conductive adhesives have been regarded as very expensive, and they've been used more in high reliability applications like medical or military applications, where they've needed that reliability. But to bring it down into a consumer product means that you must have been able to find a way of reducing cost.
Yeah, absolutely. You know, part of our innovation portfolio, we've developed a technology called silver-plated copper, and basically typical electrically conductive adhesives or even die-attached materials are pure silver. So what we've done is we've taken and put a small coating of silver around a copper flake, and are able to reduce cost for our customers with this technology, and giving them good performance, both electrically and with formulations in the resin systems. The non-corrosion comes into play with this as well.
Okay, so the electrical conductivity is of an acceptable standard to be able to meet their requirement.
Absolutely.
Right. Okay, great. Well, Doug, thank you for giving us a run through on all the new products you've got this week here at Apex. I know that with the combination or the conglomerate of companies you now have, you're getting inundated with new innovations all the time. But thanks for that. This is Trevor Galbraith reporting from the Henkel booth here at Apex.